Okay, so hello, welcome everyone for coming here to the Insider's Insights on the Top 5 Industry Trends panel session. So I'm Katrina Novakovic and I'm going to be your moderator for today. I work for Red Hat in what's currently known as the United Kingdom, and I focus on customer experience and engagement. When I've been talking to customers, they've often been asking about kind of looking at, they wanted a topic at, when I was talking to customers, they wanted to come to Summit to do a session that was a high-level, non-technical session focusing on kind of the dominant trends in the industry at the time. So today we're going to be covering microservices, containers, DevOps, Internet of Things, and big data. And when we're going to be looking at these sessions, looking at the definition of these terms, how they relate to each other, the impact and relevancy on business through customer use cases, and the relevant solutions that Red Hat offers in each of these areas. Due to a shortage of time, we're going to ask for questions at the end of the session in the Q&A section. So joining us today, we have 5 Red Hat panelists with us. We've got Mark Little, who's the JBoss CTO, Vice President of Engineering for JBoss Technical Direction and Research and Development at Red Hat. He's going to be our panel expert for microservices. Joining us, we also have Mark COGGIN. He's our Senior Director of Solution Marketing within the Infrastructure Business Group at Red Hat, and he's the former Head of Product Marketing for RHEL, Rev, OpenStack, and Containers at Red Hat. He's going to be our panel expert for containers. We also have BRYAN CHE, the General Manager for Overall Cloud and Product Strategy at Red Hat. He's going to be our panel expert for DevOps. And we also have James KIRKLAND, who's the Chief Architect for the Internet of Things and Intelligent Systems at Red Hat. He's our panel expert for the Internet of Things. And then we also have IRSHAD RAIHAN, our Senior Principal Product Marketing Manager for Big Data and Storage at Red Hat. He's going to be our panel expert for big data. So today, everyone wants things done quickly. If we can't deliver this, then people will look elsewhere for a solution. When it comes to software, time to market is very important. Development life cycles have moved from being 12 to 18 months to just 2 to 4 months, or even just a few weeks. Customers are concerned with cost, efficiency, and automation. This means we need a new way of working, new technologies, and new processes. To get through this transition, we need to understand today's dominant trends, which are microservices, containers, DevOps, Internet of Things, and big data. So let's look at the definition of each trend. What do they actually mean? So I mentioned we need a new way of working and new technologies. One change is a new application architecture, moving to something called microservices. So Mark Little, what are microservices, and how do microservices impact the architecture of an application?
We on? Yeah. Okay. So in 90 seconds, microservices are small, independently developed, independently versioned, and independently deployed components or services. What they are not is necessarily small. People fixate a lot on the some things said about 18 months ago, a microservice should be 6 lines of code. That might work in some areas, but in enterprise middleware, for instance, that's not really practical.
Thanks, Mark. And it's been said that when building microservices-based architectures, something called containers is an excellent choice, as they are an enabling technology for microservices. We have a new container-based infrastructure concerned with deployment and packaging. So Mark COGGIN, what does that mean? What is a container?
Well, as often as I talk about containers, it is a hard topic to describe in 90 seconds. But fundamentally, containers do a lot of the things that enable componentized application architectures and microservices that Mark described. They also facilitate DevOps and efficiencies in the dev cycle because they more clearly articulate what needs to be in the container as an application set versus what needs to be in the infrastructure host running the container. So it delineates lines of responsibilities between the development teams and the infrastructure teams, but it also enables and facilitates componentized application workloads like big data and even Internet of Things, which are smaller form factor generally as well. But basically, it is a set of technologies that allows you to componentize, to distinguish and set the operating system into a smaller footprint and distinguish the application itself, which drives then portability, efficiency, and better resource management. So that's probably the best summary for containers.
Thanks, Mark. So Mark's just spoken about containers as a technology. To go with this technology change, we need to look at the people and processes we use to deliver these applications. So we hear the phrase DevOps used as a new process for development. So Bryan, can you enlighten us on what DevOps is?
Hi, DevOps is an IT approach that focuses on two goals. The first is that you want to get better quality software. The second goal is that you want to improve the speed at which you can deliver that software or technology to market. It's really easy to go really slow and get something high quality. It's really easy to get something fast out to market and have poor quality. The trick is, how do you do both simultaneously? Now, from a DevOps perspective, what it does is it combines a number of different technologies, a number of different practices or processes, and also changes organizationally in terms of culture and how your people work with each other to be able to bring about these kinds of changes to deliver better software faster. I like to use an analogy to sort of explain how DevOps does this and how it sort of fits in with the other things that IT and your organization is responsible for. A lot of people will often compare DevOps to adopting a manufacturing approach. So today, when people build out systems and they build out tools, everything is very handcrafted. It's like you're building it in a workshop, right? So this is my specific virtual machine tailored with this image running this particular application. From a DevOps perspective, we transition that to a much more accelerated manufacturing approach where we can bring things down an assembly line. Things are very repeatable. Things are very automated. Now, if you're going to adopt a manufacturing process, then you also need to take a look at where am I going to apply that DevOps or manufacturing approach. And so you need a factory to be able to run this overall process. So that's where something like cloud computing comes in, and you often see a tight affinity between DevOps and being deployed in new cloud environments. And that's because you can think of a cloud as giving you that new scalable platform that can start to support the manufacturing process needs that you have. You know, if I apply very rigid manufacturing process, but I'm still within my workshop environment, then I'm fundamentally limited in terms of the benefits that I can accrue from DevOps. And then similarly, if I have a new manufacturing approach with DevOps, if I have a new factory with cloud computing, what am I going to build? Am I going to build the same old things I did in my workshop before, something like a horse and buggy cart? Or am I going to build something that takes advantage of the fact I have a manufacturing process and then a factory? So something like new next generation digital services, cloud native applications, but things designed to take advantage of these new processes and these new technologies. So that's the goal of DevOps. How do we get better software faster? And it relates to a lot of these new technologies that people have been talking about as well.
Thanks. So we've looked at microservices, containers, and DevOps, which are changing the way we deliver IT solutions. One of the reasons we are changing is that we have access to more information and data. One trend here is the Internet of Things and the move to embed sensors and provide information for more and more devices. James, please can you define the Internet of Things and also what impact you see it having on IT and the other trends that we've discussed?
So if you look at it, there's about as many definitions of IoT as there are sensors and mobile phones and things like that out there. So it means everything to everybody. I think specifically when you look at it from a Red Hat perspective as an enterprise IoT company, you know, the base definition is sensors that are out there that are IP connected or connected through Bluetooth or some other mechanism, and then are talking through intermediaries or directly back to the cloud. It's machine-to-machine exchange of data. So you have this history of having embedded systems and sensors out in the operating technology world. These are now being connected to the IT world and to the internet. And what you have is potentially scary and insecure, but if done right, can drive a huge amount of business value. So you have the ability to interconnect all these different independent pieces of business together and drive huge amounts of business value from seemingly unrelated pieces of data. So, you know, IoT is not a technology. IoT is a series of use cases that ride on top of these technologies and other emerging technologies that are out there. So it's important to remember that IoT itself is just these use cases, and in every implementation, you may have things like asset tracking, you may have fleet telematics, you may have these other use cases. You know, it's different flavors and implementations, but the technologies underneath, like big data and mobile and microservices and using DevOps and containerization, that those are the technological engines that are brought together to solve these problems.
Thanks. So having more and more things online creates more and more data. The value isn't in collecting the data itself, but in the analysis of the data and being able to make timely decisions so you can adapt to help with business management and decision making. This leads us to our final topic, big data. So IRSHAD, what does big data mean, and what's the difference between big data and just data?
What he said. No. And in a lot of ways, really, IoT and big data are probably some of the most abused terms in the industry. Maybe cloud is probably up there as well. But, and that's exactly the point, right? It means different things to different people, as James said, right? And it also depends on what angle you're attacking it from, where you're looking at this from your perspective. So I tend to use the people process technology framework to define big data, because if you look at it from a people standpoint, right? Big data, you could argue, is one of the single most drivers for the CIO to have a full seat at the C-suite. Right? IT is no more a cost sink. It's truly delivering value to the enterprise. Brick and mortar enterprises are now data enterprises, whether they like it or not. They're competing on data. And that has been a fundamental change, right? So that's the people part of it. The process part of it, you know, one of the definitions you hear about big data is the 3 V's, right? Volume, variety, velocity, which is great. But really what that means is that the processes in the way that you process this data has to change, right? The tools you're using to process the data has to change, right? We've gone from single pass analytics to iterative analytics. Your queries are no more canned queries in a single BI dashboard. They're much more ad hoc type of queries. Your data formats are not consistent. They're inconsistent formats. They're anything from documents to texts to of course your structured data as well. So you've got to take all of that into consideration, and your processes have to be defined accordingly. And finally, technology, right? One of the key things that has made big data possible is the democratization of the analytics, right? Stuff that was available only to, let's say, the Googles and the Facebooks of the world, right? Is now available on x86 hardware. You're able to use open source hardware, open source software. Hadoop is a great example of an ecosystem that is entirely open source driven and that has made that democratization possible. So that sort of, if you define it as people, process, and technology, I think you get a little bit more rounded view and definition of big data.
Thanks. So we've defined the 5 trends, and before implementing them to change architecture, infrastructures, and processes, it's important to understand the impact and relevancy on businesses. So Mark Little, let's start with you. Please can you share a use case for microservices?
Microservices are a fundamental change to the way in which you develop the architecture of your application. So, any use case you can think of where you want to take your monolithic application and decompose it into services, as I said earlier, that can be independently developed and deployed and versioned, is a valid use case for microservices. We see a lot of use of microservices in fintech at the moment, where they're kind of moving towards more agile development processes, away from waterfall. They want to do releases a lot quicker, using containers, using DevOps. And to be perfectly frank, we're also developing or redeveloping our applications using microservices for exactly the same reason. We can no longer, as an industry, release major versions of our product every 18 months. We need to do it a hell of a lot quicker. So decomposing things into microservices so we can have lots of teams developing them concurrently and releasing in a lot shorter cycle is beneficial to us, and hence it's beneficial to our customers.
Thanks. And Mark Coggin, how are containers used in the real world?
So I think there's a consistent theme, and Kat probably had Mark and myself sit next to each other because microservices spills very nicely into containers in terms of use cases. There are 3 fundamental use cases we see with customers deploying container technologies. The first is really those who want to take an existing application, a very traditional, we often refer to them as legacy applications that are very core and critical to the business, but re-platform them in a way that makes them more portable onto a modern platform. And containerization can allow you to basically wrap and make portable and re-platform an existing application. The second area is very much like the microservices example that Mark described, where you're componentizing an existing application into smaller parts, and as a result, able to create new application architectures and do things in a much different and more agile way. And I'll come back to this example with a more specific use case for it. And the third is very much a traditional, a new age cloud-like applications that are being developed from scratch, but are being done with an integrated platform with application lifecycle management and integrated development tools that go from development to test and staging all the way into production and give a full view of that lifecycle from start to finish through an integrated platform. That's the third sort of platform-oriented use case that we see with a product like OpenShift for containers. The second use case that I'm going to give an example, and Mark described financial services as being one industry sector that's grasping this technology pretty quickly. Imagine an existing application that an investment bank or a trading firm has, and they want to really change the way it's built. And so they could take an application and divide it up into parts. Maybe there's a scalable front end that they need because they're traders, and traders' desktops access the systems. So web front end. There's a core set of algorithms that are used for quantitative analysis or risk management that drive the way they place trades. And then there's maybe a third section that has to do with market data feeds. And so you can imagine that all of these things work together, but they all have different requirements. The web-based front end for their traders may need to scale based on certain peak demands and trading volumes. So this has scalability implications. The core algorithms may be the secret sauce for this investment bank and how they are profitable and competitive. So maybe these sets of applications need to be refined on a daily basis and modified and A/B testing to really find the best trading algorithms that result in the best profits for the firm. So this has very quick development and replacement cycles. And then the back end may have requirements for high availability because it's a market data feed, and if those data feed systems go down, it stops the whole firm from running. So those have HA or DR requirements. In a container world, you can imagine that you could actually implement with your application architecture as a componentized set very different requirements for all of those three. Today, when you have a monolithic application, it's nearly impossible to distinguish the requirements that may be unique within the application itself. So that's one specific use case that I think highlights the power of the technology, both microservices and containers, really.
Thanks. And Brian, how have you seen DevOps successfully implemented?
There was a McKinsey study that came out a couple years ago taking a look at the average IT project across enterprises. And the results of the study was that for any given enterprise IT project was typically about 30% over budget. It was only 7% late, but the reason it was only 7% late was because it only delivered half the features that it was originally scoped with. So again, when you take a look at DevOps, it's all about how do we get better software faster? And you need to be able to consider that in two different dimensions. The first dimension is, well, how do I improve what I'm already doing, what I'm already running in my environment? And so just as a couple of good examples, we've got customers like J.Crew or Riot Games, which is an online gaming company. And they needed to be able to go ahead and figure out how do we accelerate our ability to be able to get new capabilities to market when we already have applications that are running. And their big challenge and bottleneck was, we need to be able to start to automate everything that we're doing because it's a whole bunch of manual processes and it's taking us way too long every time we need to roll out a new feature, we need to upgrade our infrastructure, we need to make a change in our application environment and so on. And so the big win that they got from working with Red Hat around DevOps is now they have systems and processes in place where you can go into an empty data center, just the servers that are racked there with just a few clicks of a button driving some huge fleet of scripts, everything is up and running. So from empty data center to live production in just a few minutes. So that's the kind of speed and agility that customers are able to improve across existing environments. Now, the other big change is, well, if I'm going to build something new, how do I start to take advantage of DevOps as well? And the opportunity when you're doing something new is that you can change a lot of the ways that you build applications and bring them to market to fully take advantage of DevOps processes. So I'll use another example, which is actually Red Hat ourselves, because we practice DevOps internally as well. Now, a lot of you will probably remember that there was a very famous security incident a couple years ago, a Heartbleed. You guys had to go change all your internet passwords everywhere. And this was because there was a security vulnerability in the SSL libraries, which is a core piece of the Linux operating system. Now, of course, we had the patch and the security fix available as soon as the embargo was lifted on this particular vulnerability. But one of the other things that we realized was because this was such a critical issue for our customers, if they went and they patched 90% of the systems across the environment, and they had that one server sitting in the corner that they've forgotten about and it's been running for 5 years and no one knew to patch it, that's a backdoor into your system. And so we decided to build out a security scanning tool where customers could deploy this into environment to figure out, show me all the systems that are vulnerable to Heartbleed, so we understand where we need to patch in addition to having the patch available. Now, we went from first line of code to create this online service to full production across our millions of customers and systems in less than 24 hours. And this was because we were practicing DevOps ourselves. So, in the past, it would have taken us more than 24 hours just to put in a help desk ticket to get a developer system up and running. But, because of these changes, we were able to get full production system online, for such a critical business, challenge. This is something that was so important for our customers. Being able to respond to them so rapidly was another huge advantage that we were able to accrue for our customers because we were practicing DevOps.
Thanks, Brian. And James, how is Internet of Things being practically implemented today?
So I think that Internet of Things is difficult because it crosses, just as you have within IT projects that cross different silos within IT, this crosses outside of IT and into the core operating areas of the company. So the first project that's picked is really important because it sets up a set of processes and practices and templates for everything that's going to influence what happens, but it also needs to be something that is finite and solvable. So we've worked with multiple transportation customers to solve in transit fare collection and tracking of customers for to see how long they're on the bus or the tram or the train or whatever. And so those are finite projects that you start out in there, and they're very well defined. But what you're really building is a communications infrastructure, and you're building data repositories, and you're building security practices and maintenance, physical maintenance of the field assets. So you have to establish all that. But then, usually what you're doing is you're automating something or integrating something that pre-exists and making it more efficient. So whether it's, going from time-based maintenance to going to maintenance when there's an actual issue and being able to track, that there's actually a problem. So you're able to just do just-in-time maintenance and predictive maintenance, or whether it's solving the fare issues or whatever, you're solving a real problem. But what you find quickly is that you then have other insight into other things that you didn't know were there, and you have new services that you can begin to offer as well. So in the transit space, you begin to understand that you realize that your customers, there's some that are on there for long periods. There's some that's on for short periods. You can predict demand better. You can figure out dynamically how to move trains or buses in and out of service to have just enough that are there. You can then begin to do things like offer services to retailers to help retailers understand when they're going to have peak traffic flows in the areas where their stores are. So these data sets, when you look at smart cities, for example, smart cities starts out as, how often do I collect the trash, or how do I track these Boris bikes that are rentable bikes and things like that, and street light maintenance. But it turns into a big data set that you can offer to folks in real estate and retail and people like that, that this data then affects real estate values because you know the foot traffic and the automobile traffic and transit traffic that goes in front of it. So it begins to balloon as you get more variety of data that comes together. The insights become more complex, and you're able to do things you never would have contemplated.
Thanks, James. And IRSHAD, please can you share with us what customers are doing with big data?
Yeah, there's a lot of interesting things going on out there, right? There's a couple of use cases I'd like to share that have a little bit of crossover across the panel here, right? The first was, this was a Canadian telco based in Saskatchewan. And what they found was that a lot of their mobile subscribers would cross over the border into the U.S. And incur roaming charges. And obviously these were carried by their American counterparts, the telco providers that they had to sign up with. Right now, this is a classic, going back to the people process technology framework that I built up earlier, right? Where the CEO and the CFO saw this problem. And the first person they thought who could fix that problem was the CIO. That's a huge change, right? And that's primarily because of things like big data and IoT, right? And so they went to the CIO and said, look, this is the problem. What can you guys do? So they sat down, their IT department, and tried to figure out, is there data that we are already collecting that could maybe give us a clue into how to improve this billing? And they were actually losing millions of dollars, right? And so what they found was every time you make a phone call, there's, I think, 214 records in a database that are filled out somewhere. Makes you think, huh? So what they found was, all this information was, anything from call quality to the cell phone towers to how long the call was, who it was made, all that stuff, right? And they found that there was actually a field that they could use to exactly track the roaming charges, because if you were mid-call and you crossed the border, you'd only get charged for the part of the call that you made in the U.S. All of that stuff. So they were able to take that data, right? So this is a classic IoT / machine data / big data kind of a problem, right? Where they were able to start logging this data and querying for exactly that. And what they found was this stuff adds up very quickly. It's 214 records every single phone call, right? That's a big data problem. So one of the solutions they came up with was to use Splunk for machine data analytics, and they put all of that onto Red Hat storage, which is highly scalable. You can use x86 commodity hardware, so you're not breaking the bank, but you're able to do all these cool analytics with Splunk, and you're able to scale very easily. They were going from hundreds of terabytes close to the petabyte scale very quickly, right? So this stuff adds up very quickly. And what they found was they were easily able to find those queries on the fly and bill their customers on a monthly basis. So classic example of where data was able to come to the rescue, and this was data they already had, right? Dark data is one of the terms that's out there. So that's a classic example of being able to quickly extract value and be able to deliver that back to the business. The other one is, this is from the financial services industry, where there's a large financial services institution that's using containers to run analytics, and they're running this again on Red Hat storage. The idea is that going back to the point about microservices, right? Rather than running large monolithic pieces of code, you want to be able to break them up into much more modular fashion and be able to run that on containers. What they were doing is essentially providing a data as a service to their internal stakeholders. So lines of businesses that wanted to run analytics that weren't possible. They had a lot of shadow IT, right? People going to Amazon and to the public cloud, and so they wanted to stem that as well. So two good examples of being able to use open source software, use industry standard hardware, and being able to solve some of these complex problems.
Thanks for that. So moving on to the last part of the session before we have Q&A. We'll discuss the solutions that Red Hat currently offers to help you plan and transition your business and IT strategies. Some customers get confused at how Red Hat can help them in each of these areas. So for example, you can't just buy a microservices subscription or a DevOps subscription. They don't exist, and it doesn't really make sense. So when speaking about the use cases, we've already mentioned a few of the products like Red Hat Storage, but let's look at each of the trends in more detail. So Mark, with microservices being a new application architecture, is this more related to the Red Hat JBoss middleware products and services?
Yes and no. So if anybody saw Paul Commier's keynote yesterday with the demo that he did, or that Burr Sutter and various people did, hopefully you'll remember that one of the things that that was based on was OpenShift. So OpenShift is a great platform for developing microservices, container-based, uses Kubernetes and Docker under the covers. Got CI/CD pipelining built in, so it kind of fits into several of the things that we've been hearing from the rest of the panelists. But middleware does fit into that as well. So again, looking at the keynote, we demonstrated things like Vertex, which is a great example of polyglot, asynchronous, event-driven framework for developing microservices. Many of our other products also fit into the microservices paradigm, and one that I will point out is something that we're doing called Wildfly Swarm. So based on our application server, rather than, as some vendors do, assume or require that if you're going to do microservices, you essentially have to start from a green field. We can do that as well, for instance, Vertex. But if you've got a lot of built up legacy code, or people who have skill sets in the Java EE environment, for instance, then you want to start on that and decompose your existing Java Enterprise application into constituent microservices, and that's exactly what Wildfly Swarm does. And in fact, on Monday we announced an open collaborative effort to standardize some of that with IBM and Tommy Tribe and a number of Java user groups, as well as the Pyara guys.
Thanks, Mark. And so for containers, as this is related to a new infrastructure, what offerings does Red Hat have there?
Well, containers also, you really are going to see it and are seeing it spread across the portfolio of Red Hat and how we address container technology. Mark described OpenShift in the demo yesterday as being the integrated platform with CI/CD pipelines and integrated workflows and provisioning from dev all the way to production as one example of a fully integrated container application platform. But diving down into a few of the piece parts that exist in the whole portfolio of Red Hat, you realize you need a stable host platform and operating system to run the containers. That's where Red Hat Enterprise Linux and RHEL Atomic Host come in. You need to contemplate the things that Brian was talking about. Where do you get your containers? Are they trusted and secure, up to date? And that speaks to container registries and container scanning technologies that we are developing and also working with partners like Black Duck. You think of how do you manage the containers? How do you set policy for them? Because they fundamentally are an application that goes into the wild, but you have to keep track of it. So you know when to decommission it, who has access to it, how's identity controlled, and what are the other requirements and policies set for that application in a container. So that speaks to a product like CloudForms, which has container management built in. And then, of course, we all know that containers are, while being used for cloud-native stateless applications, many of them will be developed for stateful applications and require persistent storage. And that's where our software-defined storage portfolio with Ceph and Gluster come in and can create storage volumes that are persistent and attached to even individual containers. So you see our offerings from Red Hat all being enhanced to take advantage of and address this emerging trend of container technology.
Thanks. And Brian, how does Red Hat help customers to enable Red Hat DevOps adoption?
So Red Hat has a three-pronged approach in terms of how we work with our customers around DevOps. Now, DevOps is not something you can buy and install, but instead it's an approach from an overall IT perspective. So the first thing that we work with our customers on is how do they open up their culture, because you can buy all the technologies and install all the latest and greatest stuff, but if you don't change your approach in terms of how you leverage them and how you build software, you're not going to get the results you're looking for. One good example of how we can help our customers is we have a relatively new offering called the Red Hat Open Innovation Labs. This is an opportunity where our customers can come on site physically or virtually to work on a sustained engagement with Red Hat engineers to learn about here's how we put DevOps into practice, here's how we go ahead and release a project and take it from soup to nuts and learn everything around how we accelerate and improve the quality at which we bring that software to market. So this is where we can teach all the organizational aspects, the cultural aspects, the process aspects, and so on. And this is something that's a very interactive and engaging experience. But it's all around this goal of how do we help you open up your culture, because if you don't change your culture in your organization, you're not going to get the results you're looking for. Second thing that we can work with our customers on is what we call automate to accelerate. So if you go back to those examples I gave around J.Crew or Riot Games, for example, and how they were able to go into their existing environments and then bring tremendous automation to speed up, how do they improve the delivery times of what they're doing. Automation is fundamental because the only way you're going to get improved speed and better quality at the same time is if you automate the processes. You take out the room for human error, and you can take advantage of machine speed to be able to get things to market. This is where our Ansible technology comes in and plays the lead for us, because Ansible is a fantastic tool for automating everything around your environment, from how you construct your core infrastructure all the way to how you deliver your applications. And so, for example, J.Crew and Riot were both Ansible customers leveraging that technology to be able to accelerate and improve what they were already doing. The third area that we focus on is, how do we help you improve around, new application development? And this is what we call Evolve to DevOps Native, and where you're able to take advantage of a lot of the new technologies that are just intrinsically better for doing DevOps. So if you go back to that example I gave around Red Hat and how we were able to get that new online scanning tool to market within 24 hours, that was because we built it on top of our OpenShift platform. So Red Hat's own instance of OpenShift, where we service our own customers. Now, we were able to take advantage of all the capabilities within OpenShift to give developer self-service. We were able to run through our continuous integration and deploy pipelines that were built into OpenShift, and then get into our production environment, which was also on OpenShift. So OpenShift was able to provide us a platform that was optimized to take advantage of how do we take these DevOps practices and run them in a more native way across technologies. And that's the third dimension where we work with our customers.
Thanks. And James, for Internet of Things, what does Red Hat do in this area?
So, again, I think when you make decisions about the Internet of Things and going and implementing, you have several choices that you have to make up front. There are vendors that are out there that say they will provide you a soup to nuts, complete stack solution, and can solve all of your problems. I generally would say be very skeptical of that, and potentially I would say run the other direction, because even if they can, it's going to be incredibly expensive. I think what you're going to see is these coalitions that come together of a variety of companies. Red Hat provides IoT solutions to its customers and partners, but in specific areas where we have expertise and we have products. So things like Fuse for integration and BRMS and containerization, running in OpenShift. There's a lot of good technologies that we have that can make implementing IoT systems easy. Whether you go to a partner like Accenture that has their CPaaS, which is a platform, and they go and they help you implement it, or whether you want to go and you work with us and our partners, Eurotech and other partners, you have to buy into an ecosystem that I think has a few fundamental values. One is that it's based on open standards, so that you're getting the ability to pick and choose different companies and products and projects that you can interconnect together and that can change as your business changes, either from a business perspective or a technical perspective. And then secondarily, I think it needs to be based on open source. I am obviously a bigot, and I think you then have to make the decision of whether you just build all this yourself or whether you buy. And I think when you look at the sunk cost that goes with maintaining these pieces of infrastructure software, be it middleware or the different platforms that we have like OpenShift, or even the core infrastructure of containers and Linux, you want to have open source is about standing on the shoulders of giants. You want to pick somebody like Red Hat that's going to be able to provide you 60 or 70 or 80% of the functionality that you need, and then you're working in your core area of expertise and building on top of that. You don't want to have your developers and engineers and hardware and software engineers in the field working to maintain core pieces of infrastructure. You want them understanding your internal problems, your customers' problems, and working to use our tools and our partners' tools to build solutions. So it's really about understanding the use case. I think picking things like Fuse and a good underpinning of RHEL and messaging and all these different things and bringing them together to solve it in the best way possible, rather than going to one company that's going to lock you in for the next 20 to 30 years. And that first bite of the apple may be cheap, but it's going to be really expensive, not just in terms of cost, but in lost flexibility and inability to take advantage of things like DevOps and microservices. You want to have partners that are going to give you flexibility and not lock you in.
Thanks, James. And IRSHAD, big data is mostly about storage, integration, and analytics. So what's available from Red Hat?
Yeah, and so everything that James said really does apply to big data. And again, going back to the point that I think Red Hat is in a great position to be able to offer. You can't come up to Red Hat and say, I want to buy a big data from Red Hat, right? However, we do have all the pieces that you need to solve your particular problem. And that's going back to what James said, right? If you look at the industry out there, there's a lot of one-size-fits-all type of solutions. And that's not the way, that's just not the way. We have a few tenets here. That's the Red Hat way, right? These are some of the core elements of our DNA that span across everything that you're hearing about today, right? And so being open and agile and deployment agnostic, because containers and cloud is not a matter of if, it's a matter of when. And so if you plan from day zero to be container and cloud friendly, it's a lot easier when you're ready to make that transition, right? And so the other advantage that we have is we're not sitting on legacy hardware, right? We're not trying to push a certain type of server to you, right? We don't sit on a Hadoop distribution, or so we can truly be neutral and truly be a trusted advisor to build the workload, to build a solution that solves the challenges of your particular workload, right? The way we think about the product pieces, it's a lot of what's already been mentioned, right? If you break the big data cake into two layers, right? You've got sort of the applications and integration layer on top with things like OpenShift, the entire JBoss portfolio essentially, so data virtualization. So if you've got a number of data sources, you want to be able to consolidate those data sources, or data grid for in-memory analytics. And there's also optimizations for things like Apache Spark, for instance, where there's integrations into OpenShift and into a BRMS, for instance. And then you've got the second layer, the infrastructure layer, right? That's where things like storage and RHEL and Atomic and OpenStack come in. And again, there's integrations into some of the big data pieces, things like Hadoop, for instance, right? So we're working, to be able to enable you to build a solution that makes sense for your particular workload, right? So those integrations are important. The partnerships are important. And again, going back to something that James said, there's one vendor who can tell you that we can do it all. It's just not possible. Partnerships is the name of the game, which is why it's not just open source, but being open and being able to build these on industry standards is key to us.
Thank you. So we've given you lots of information to think about microservices, containers, DevOps, Internet of Things, and big data. And so now it's your chance to ask any questions that you have to the experts here. So if you please want to raise your hand, and we'll have a microphone come over. If you want to state your name and then your question. So Anna, we've got one in the front here.
Be gentle.
I'm going for you.
Oh, no.
My name is Chris Waywak. I'm with Red Hat. IoT nodes are often treated, the sensors you deploy in the environment are often treated as like unchanging, almost disposable appliances, which is kind of a nightmare for security. You mentioned Heartbleed. So how do we protect those? I have a wireless router in my house that I can't update. So how do we protect these IoT nodes, and how do we, when you're thinking about how you make something enterprise strong, how do we account for the security aspects of IoT going forward down, years later?
So I think we have to transition beyond the embedded systems mindset to more of an IT mindset for managing these, first off. And that's a big transition for the operational groups. They're not used to this and they don't have expertise in this. So I think it's a process and mindset change, first of all, within companies. Secondarily, you're going to have a layered approach to security. Devices will be compromised. You have to assume that you have to have built into the network, built into the data streams, built into every facet of it security so that you can detect as quickly as possible. And you're going to need not just host-based intrusion detection, but network-based intrusion detection. And you're going to have a big data mindset for all of your traffic where, you know, security is really linked inextricably to data. You have to build the ability to have context around every piece of data so that you understand how long it's supposed to live and how you secure it, how it's encrypted, and whether it's encrypted together, whether that piece has to be encrypted. Because my personal data, I don't want pushed together with someone else's personal data and encrypted. I want it individually encrypted. Versus anonymized data, which you know, could probably be amalgamated, but you know, people think that telemetry by itself doesn't have to be encrypted. But if you ask the Iranian government with Stuxnet, you know, whoever was able to destroy the centrifuges because the telemetry data was spoofed and it was showing normal RPMs on those centrifuges when they were spinning themselves to death. So you've got to look at aggregated data because they say with 3 credit card transactions, not knowing who someone is, they can identify you. So it's also understanding that in aggregate information and in telemetry information, there's just as much danger, and I think that's another key. And again, it's recognizing that security is process as much as it is tools. That if you have great tools and then you're not updating constantly and vigilant, you know, day one you're safe, and then day 2 you're not. So it's you know, exponentially harder. But if you build the right process and just build security into everything, it's something that getting started is hard, and then maintaining it is just process.
Thanks. Question over there, Anna. She's on her way.
Got 15 minutes left.
Hi, my question is for the DevOps. So you mentioned about repeatable processes and trying to automate everything. Having said that, in order to kind of make sure that every process and whatever you do is repeatable, you're kind of constraining yourself to a set of fixed processes and a set of fixed code structures, right? So how do you bring the element of innovation over there? How does DevOps kind of keep on ensuring that you're kind of plugging in the innovation element or the innovation aspect as well?
Yeah, so just because you automate everything doesn't mean that it's rigid in terms of, you know, if A, then B, and you're following a chain set of rules. If you take a look at a lot of the systems that we can put in place with tools like Ansible, for example, what we're doing is we're describing what is the end state that we're trying to achieve. You know, we're trying to set up, you know, this set of applications or this set of servers, you know, configured to run, you know, this kind of workload. Now we can apply that set of automation scripts onto different environments. So maybe I'm going to the public cloud, maybe I'm going to OpenStack or onto bare metal, and so we can automate and account for the changes to say that, you know, in these environments, this is how I get to my desired state. In this environment, I take another approach to get to my desired state. But what I'm automating to is the desired state. I don't have to list every single step along the way. That's one of the powers that this gives you, instead of something like writing a bash script where I have to say, you know, every single step along the way I'm just executing a very rigid program. If you take a look at a lot of the continuous integration and test systems that are putting in place, the goal is not to say that you know, I execute my program in such a way. It's to take the human action out of it. And so we can put it through an automated system which will run my tests for me, which will build it, which will integrate it for me, and then give me a result. You know, did it pass or did it not pass? If it passed, I can promote it to the next stage. If it didn't pass, I send the results back to the developer, and he has to fix his bug. But I can take the human element out of taking a look at how do I run these steps? How do I make sure that when I set up my staging environment, I didn't forget to change a configuration setting that my developer had, and so it worked on my developer laptop, didn't work in staging. Why in the world, why not? We're eliminating all these sources of errors along the way.
Thanks.
Thank you. Hi, my question is around DevOps and microservices. It seems that there's a strong correlation doing one or the other. In the real world, they seem to be going hand in hand. What are the approaches that companies take to adopt? Do you need to adopt both at the same time? What is the real world relationship between the two?
Yes, so you do often see microservices and DevOps going together. They don't have to, but there's a lot of synergy. So, for example, I spoke about earlier that one of the goals, or the goal of DevOps is, how do I get software to market with higher quality and with more speed? Now, if I have a big monolithic application and it takes me 3 days to build that application and to test it, it doesn't matter how much I automate things. It's just going to take me 3 days to get it to market. On the other hand, if I can decompose that application into very small microservices, maybe they're running in containers, then what I can do is I can take one of those individual services, I can run it through my DevOps pipeline much faster because I don't have to worry about the impact of how do I rebuild and retest every other part of my application. I've also reduced the surface area of that particular service, so I have increased confidence in the fact that when it passes my test, I understand what it's doing and that it's going to come out and actually do what I expected it to do. So that's why you see this correlation. Microservices done right with a good DevOps practice can help accelerate how you get to better software faster.
So I agree with what Brian said, although I would say that kind of the same with DevOps, but if you think that moving to microservices is going to solve your problem, just because you've said you're moving to microservices and your problem is that you've got a big ball of mud, then it's not. You have to understand what got you to a big ball of mud. So you need to understand your architecture, you need to understand the human aspect of what developed that architecture, and if you don't do that and you just start to pull it apart arbitrarily and distribute these things around in containers or whatever, what you'll end up with is a distributed big ball of mud, and that's even harder to manage. So understanding the architecture and understanding the people and the processes that got you to your problem architecture is critical before you enter any kind of revisionary approach.
Hi. Yeah, left side in the back.
They go together. Sorry.
Oh, sorry.
Yeah, they can do, but you don't have to. Yeah.
They done right, they work very well together.
Okay, question from the last row. Having all the experts on stage, time for a small question looking into the future. So I've seen some stuff around the corner called Project Lambda. So where the life cycle of a container is just the execution of a small function, taking microservice to the top, putting everything in the smallest piece possible, and at the end of the day, it's just executing containers on a microserver level and orchestrating all the stuff together to make a running system. Is there just a special use case behind this idea, or is it something we have to consider right now? Our systems that we're talking about today already prepared and designed for this, or we just lean back and wait? Any statement from your side?
I think Lambda's definitely got some interesting principles built into it, but it's certainly into the future. But there's always the trade-off. Mark alluded to the application architecture. Brian alluded to automation. I mean, there's always a point at which you shouldn't go too far. You shouldn't componentize down to the line of code. That would make no sense. So you have to assess what's the right level of fine-grained approach that you want to take. What's the level of coupling you want to take in your application architecture? What's the level of automation you want to take? Those are very open questions that depend on you as a company and your culture and your skill set that you have. So it's really, we're watching and seeing it, but it is unfolding in many of the technologies we're actively developing through the middleware portfolio, our rules engines, and workflows and BPM and everything else. So we're watching it, but it is into the future for sure.
Yeah, just add a couple things. So for those who aren't familiar with Lambda, this is basically an approach where you can go ahead and kick off some events, in terms of an application that trigger different actions without having to boot up a server underneath. That whole infrastructure is abstracted for you. The good thing about that model is that having something like a container fabric is actually a really optimal way to be able to implement those features. We actually have some open source projects on the JBoss side that have been implementing similar functionality onto OpenShift. This is still a development effort because we're still in the early days of this model. It's unclear how much traction it's going to get, but like Mark said, we're certainly actively participating in this space.
Yeah, I was just going to say the one that Brian's referring to is called Function. It's one of the Fabricate projects if you're interested in looking at it, but it is on OpenShift.
Any other questions?
Just coming.
So I think that another trend that is very related to the 5 you mentioned, it is machine learning, because machine learning requires big data and is an enabler for IoT, and probably you want to deploy your machine learning solution in a container and with a microservice architecture. So how does machine learning fits in this picture, and is there something provided by Red Hat to enable it?
Yeah, so again, going back to the point about you're going to be deploying a machine learning solution on some sort of a distributed system, right? And the point is, we had that slide earlier on where what you're seeing today didn't fall out of the sky, right? This is stuff that's been a transition, an incremental transition over time, right? And so the expertise that we bring in sort of helping you build those systems is extremely important, consulting and the services aspect of it. But also, from a product standpoint, going back to software-defined storage as being a way to be able to land your machine learning system. In addition, we have partnerships with a number of partners in that area. Right now, the machine learning space itself is quite fragmented. If you look at the vendor landscape, there are some of the giants that offer this as part of their existing solution. But again, our point is, as long as it's an open interface that can work with our systems, we're willing to support it.
And I'd just say, from an IoT perspective, most of the machine learning that you see is very, very narrow and targeted at things like predictive maintenance, things that has a very predictable outcome. And, it's not a complex multivariate problem. I mean, it's usually aimed at multiple measures around, whether something is working or is about to die, things like that. I think machine learning is in its infancy. And it still takes a lot of expertise in a particular area to guide it. I'm hoping that we'll see more algorithms begin to come out that are more generally applicable. But I think this is still 5 to 10 years out from anywhere near even the beginnings of maturity. But it's gonna have to happen, right? Because there's just not enough data scientists in the world to be able to deal with this much data. From a Red Hat perspective, what we do really well is we're able to get the right data in the right place in the right format to make the right decision. And we're well primed to integrate with any of the vendors and all of the vendors. Our whether it's messaging protocols, whether it's comms protocols, the Red Hat way is not, this is the way you do it. It's, we're going to give you a toolbox or a golf bag with a lot of clubs in it, and the club that you pick, whether it's MQTT or whether it's this or that, you've got to pick the right club for your problem. But what we have to do is we have to support, as many of the open standards or algorithms or whatever it is, or vendors in machine learning, so that you're able to pick the one that's applicable to you in the right situation. So it's, again, a part of it goes back to the ecosystem and being active in the broader ecosystem and giving you the power to choose what's right rather than stipulating what you have to do.
And I think we've got time for just one more question if anyone has a last one. No? Okay, well, we'll wrap up the session then. So now you should have a better understanding of what each of the 5 terms are, the impact and the relevancy on business, and also what Red Hat offers for each of these. If anyone does have any further questions, some of the panelists are going to be hanging around outside the room after this session, so come and have a chat to them. Also, on the website, the Summit website, there's going to be some slides available to download as well. There'll be more than just these 3 slides. They'll have some information about the panelists and also just some useful links to resources for each of the 5 trends. So I'd just like to thank our panelists for taking part today and also for all of you for coming here today as well. If you can, please rate our session on the app to give us some feedback on what we can do to improve for next year, and enjoy the rest of Summit. Thank you very much.